Hey guys, we're back. We've been off for a few days. That's not to say we haven't been doing anything with Unreal Engine. My wife has decided to go and bounce things about the kitchen just as I go live, so yeah. Yes, your mum must have made a spelling mistake, Ian. Understandable. You know, these things happen. Anyway, just a little joke aside. So, what we've done is we have done not a lot, but we have done some things. And one of the things we've done is we have tidied up the widgets in the game. So let's have a look at that. We've made some new UI items, which are basically the signal. We've tidied up the battery one, and we've just basically tightened up all our little HUD items. So we should see that in a minute. Then we're going to have a look at the wind. Now, we had a look at the wind this morning, and ChatGPT was wrong. Right? Because what it said was to put in a wind. I'll show you in a minute. It's basically a wind direction something or other, and it doesn't work in Unreal Engine, and it is a known thing that doesn't work. So you can't do it like that. So ChatGPT was wrong. I was actually just playing about with things on ChatGPT. I was asking it what missions I should use for this particular game, for a drone game, right? And basically most of them already knew. Every time I've actually asked GPT a question, it's gave me the answer that I already knew. Right? Now we've put a target down so that we know if the wind component is affecting it. So you will see that I have tightened up the UI a bit on the right hand side for the signal. I made the different values or the different UI images for the signal. We've tightened up and added the battery component. No, I don't actually, because you can't, because ChatGPT can't do blueprints, right? And every time I've asked it a question about programming, it's given me the answer that I already knew anyway, right? I do it more for a laugh, just to see what the answer it will give me, and if it brings up something that I haven't already thought of and it's never actually done it yet, right? So yeah. So, as you can see, our grenade should, if we did not add a wind, it would hit that straight on, okay? So, now, you'll notice that it doesn't fall straight, right? Which is exactly what we want. I'll show you that again, right? So it's not falling straight, because our actual thing, our wind, and I'll show you how I did it in a second, but you'll see that we can, if we hit an ammo box, right? So I am going to show you what doesn't work and what does. So if you go down to here, if you click on the add, right, and you go to all classes, right, and there's a wind directional source. Okay. Now, the way I thought this was going to work, and the way it's described in ChatGPT, is that there's a strength and a speed and a direction, right? Now, the direction just comes off the widget itself, right? And it doesn't change, because I did a few tests to see if the wind direction changes, and you can't pull the values out, right? So basically, you've got a gust speed, a minimum maximum gust speed. So let's actually add this, and I'll show you what I mean. Right? So we've got this wind component, right? Wind direction source, right? Now, what I did was I mucked about with these values, and it did nothing. And then I checked it out, and it's actually on the Unreal Engine roadmap and hasn't been implemented yet. Right? So we have to forget that. Okay? Because if you add a big huge strength, then a big radius and a speed, it does absolutely sod all. And you can't bring it back, right? So you can't query this component and say what is the strength or what is the speed, right? You can do the transform, but you can do the transform for any component. So fundamentally, we found out that it's incorrect. Okay, so we shall just remove this again, because, as I said, it is fundamentally a waste of time and doesn't work. So what we actually did was we actually added impulse to our bomblet. Okay, so you'll notice that we're doing it in the X direction. Now, if we turn, we can now get a wind component, and we could use it from like the day-night cycle, right? That's if we end up doing that. So we're going to check that out, but not yet. We're going to do our own wind component first, right? So what we can do is we can set up a wind component and then add an impulse based on the direction and the strength of the wind. And I'll show you how that works. Now, if you were watching before, you will notice that it goes to the top. Okay? But if we do minus, it should actually fall on the minus. Right, now this strength is just to show you we're not taking the direction, but what we're going to do is we're going to change the direction, right? And then we can just multiply this impulse by the strength. And I've just been trying to work out how strong or where the clamp should be, right? So yeah, so we're basically dropping. We can check it, because when we run it we can see what height we're at, right? And we could actually work out the real physics of it if we wanted, because we can get the mass of the bomblet, right? So if we use a heavier bomblet, it's going to affect it less if that's what we include in our calculation, right? And then obviously the strength of the wind, right? So the idea here is we are going to create a wind component, and we're going to base it probably we could do it based on the weather, but we'll check this out first, right? So where is it you're from, Sunbuster? I thought you were from... Yeah, that was the two possibilities to use, Ian. It was radial force and the impulse. The impulse becomes a constant effect anyway, right? Because if you put it on tick, right, which I know you should stay away from, but it works well in this instance. And if you use tick sparingly, you know, you're only ever going to have one bomblet, and it's only going to fall for so long. Right, so either or, the radial force or the impulse works fine. And if you do the wind component, you can add your gusts into it, right? So if we do it on the minus and we drop it, we should see it falls to the bottom, right? So that's working exactly how we want it. Oh, where about in England are you? Yeah, but you're right, it was the radial force and the impulse that were the two options to use. Right, now I'm not familiar with the radial force thing, so I just went with the impulse, stuck it on tick and went, yep, that works. So what we can do now is, if you notice, we can change that back to 0.5, right? And in fact, what we'll do is we basically need to... Oh, East Anglia, you're talking Norwich, Ipswich area. Right. Okay, so what we need to do now is we actually need to create a component. Or actually, you know what? What we're going to do is we're going to create an actor, right? So let's think of where we're going to do this. In fact, let's create a folder, right? I do like a good folder. And we're going to create a folder and we'll call it wind actor. It is going to have a transform because we're going to stick it in the actual level. So yeah, we'll just do a blueprint class. Right, and we'll just do an actor. And we'll call it BP. And we'll just call it wind component. Right. And what we'll do is, just because we can, we'll create an enumerator, right? E wind type, right? And what we'll do here is we'll set this up based on, we'll set up an enumerator, right? So that you can actually, when we put it into a level, right, we can either, we can select a random enum or we can set it, right? So what we'll do is, as a first one, we'll just say, let's say random, right? And then we'll say calm. We can say gusty. Then we can say, what will we say? What will we say here? Strong. And I suppose we could call it Storm Force. Now, we can use this as well to actually affect the speed of our drone, right? But we'll worry about that later. At the moment, we've got 4 different, and if we pick random, then it's going to pick one of the other 4, and that's fine, right? So now what we need is going to be a structure right? So we're going to have a struct wind. Right? Now we could save this in a data table if we want, but hey ho, we'll worry about that in a minute. Right, so we shall have wind. Right, and that's going to be an enumerator, so it's going to be wind, right? And then we're going to have min strength. Then we're going to have a max strength. I'm just spitballing this, by the way, guys. I'm just making this up as I go along and trying to figure out what we need, right? And we probably want something like a has gusts, right? And that can be a bool. And then we can have a min gust, a max gust, and then direction. Now, I liked the way they did this before. How is it you move this? Who knows how to move these? There used to be buttons here. That's a float. And that's float. Okay. How is it you move these? Right. So apparently you grab it right at the edge there. Not as easy as the buttons, but anyway. Right. So our direction is a float as well. It's just going to be where it's pointing to on the X forward vector. Right. And we'll work out, well, it's just going to be an X, but we're going to move this on the Z. We're going to be rotating the direction on the Z, which is going to give us a forward X, which we're then going to multiply, which is going to give us our direction, right? So now we've got our wind component. And we probably do want a date table for this, but we'll do it in a minute, right? So what we're going to do is we're going to add our thing there, and we're going to call it struct wind, and we're going to call it wind attributes, right? And it's going to be struct wind. There we go. So we're going to set this up on the begin play. We could even set it up. It's going to be instance editable. And yeah. So basically when we drag this in, right, we've got it as a wind component. Now let's have a look at this. Right, so there is our, so our wind is pointing this way, right? So if we get the forward of this, we should be able to work with it, right? And in the first instance, alright, we're going to get active class, right? We'll set this up as a reference in a minute. In fact, let's do it now, shall we? Right, so we're going to add ref wind, right? And that's going to be p wind component. Right, so that's that. That's BP1 component. So we're going to set this up on begin play. Alright, so that's fine. We're going to set that. It's going to go in there. Okay. Doing good, doing good. Oh, by the way, anybody that's in the slightest bit interested, the reason that we haven't streamed for a while is, well, three reasons really. Number one, burnout. Right, not in any particular order here. Burnout. Number two, I've been giving private tuition at some ungodly hours. And the other reason, I can't remember. Oh yeah, I've been watching a bit of the football, which kind of ties into the burnout thing. But yeah, we're back. So it's not that I've not touched Unreal Engine. I've been working on other projects with other people and doing some personal tuition. Private tuition, if you like. So, no excuses, that's just the reasons. Right, so we're doing the ref wind. And I don't think we actually need direction. Knew it. What did you knew it? What did you knew, Mr. Taylor? And I wouldn't actually even say it was burnout, it was more being a lazy git. Yeah, watching the football, yeah. Yeah, it's a bit. Well, to be fair, it isn't really a very good excuse because it doesn't explain the missing the 8 o'clock streams, right? Which I know you guys in the UK would probably never see because it's like 2 in the morning, but. So we don't actually need. We're going to get the wind attributes, right? That is one of the things we're going to be doing, but we're going to need the transform as well, right? So basically, we're going to be doing transform. Actually, you know what? We're going to be getting the rotation. We're going to be doing get the actor rotation. Right. Now, I'm going to have to check this as we do it. So, we're going to break that rotator. Right. We're going to have to work out which way this is actually going to push it. Right. So, let's muck about with this and see what we end up with, shall we? This is where my unfortunate lack of going to school I mean, what we could do here, right, is to make it really easy. Right, what we could do is we could get the bomblet and we could set the rotation set the world rotation to this rotation, right? And then add an impulse of 0.5 on the X. Right, now that should solve the problem, right? So we should, in theory, this is our wind, right, and it's pointing that way. So in theory, if we run it, our bomblet should get pushed to the left. Right. So let's see if that is actually right. Error. No. Okay. So that's not right. Now I'm wondering. We could. Let's. I don't think this is going to make any difference, but I just want to make sure. Right. Alright, so I think I know what the iron sights is just to give us an idea of where it's supposed to fall if it's falling straight down, right, and gives us an idea of the wind effect, right? So that's the reason for that. Right. Okay. So what we need is a wee print string here. Right. And we're going to get the reference wind. Alright. And we're going to get the X. Right. And we're going to do that for now. And we're going to have to split that and plug these in, although we're probably not going to use that anymore. Alright, and we're going to set this to like, let's say 20 seconds, and then this is going to give us something that we can work with. Compile that, press play. Right, come on then, let's be having you. Right. Get this out of the way. Right. And we have a 0. Right. Now, what we want to do is select our wind component. And set this to 90. Right. Wait a minute. 180. That's not turning round. What's going on there? Alright, wait a minute. Why is that still pointing down? No, X is pointing forward, right? But when we actually rotate it, right, we're rotating it on the Z, right? You'll notice here that this changes, the Z changes, right? But this is going to affect the way that our red should be pointing, right? So, if we spin that around, right, that shouldn't be forward, okay? You'll notice the X rotation is not, it's roll, but the Z is rotation from above. Okay, so you'll notice this time that our x, if this is right, should be different, right? But it still says 0 for some reason. So that's goddamn weird. Right, am I missing something very, very obvious here? Wait a minute. Right, I'm going to delete this for now. And that's the reference of the wind, right? So it's the roll, it's the yaw that we want to rotate it on, but the x, the roll, is giving us the forward vector. But maybe we want to do, right, let's just check this, right? What I'm going to do is I'm going to recombine that, and I'm going to get forward vector on this. Right. So we're set at 0, right? We'll see in a minute if we get this right or not. If this one changes. Unreal Engine 5 being Unreal Engine 5 and going really, really fast. Not. Right. So, right, it doesn't actually matter if we aim or not here. Right, 1, 0, 0, 0. Right? So if we change this to 90, and go with it, then we shouldn't get 1, 0, 0, 0 anymore. We should get something different. Right, let's see. So, it doesn't really matter. 0, 1. Right, so that's better. Okay. So the only ones that should really change are X and Y, right? X and Y are going to tell us where on the rotation we are. Or let's have a look. this might be one of these dot product things that I don't know anything about because I didn't go to school long enough, and a big regret now that I didn't stick in at school. What can you do? All got regrets in life, I suppose. This is where we could use, whatchamacallit, we could have a go with Chat GPT. Right, we're on 100, right? So, well, that's weird. That's weird as hell. Was that -1? Because that should have been -1. Right, let's do something slightly different here. Let's do 45, right? Right, so let's see how this one affects us. So I'm expecting something like a 0.5, right? Right, 0.7. Right. So what I need here is for this wind component, right? Let's add an arrow so that we can see the actual direction, right? And we're going to make the arrow a 10. Right? And now you can see the forward direction, right? So is it actually a very simple fix? Is it actually just if we break this, right, and we just stick that in there, compile it, Let's have a look and find out, shall we? Right. What we want to be able to see that component, to be fair. Right. Right, so the bushes are on the right hand side, so we need to look at it for the right way, right? So that's the way we're going, right, which was fine. Right, we'll drag it over here, and I think that's the way it did fall. Right, now it is being a pain in the neck. Right, so let's go to BP component. Right, we're not going to say hidden in game. Right. So we should be able to see it this time. And interesting one. Right, so there is our direction, right? And that's the way our bomb is falling. So that is cool. Right, so the next thing we need to do is try it the other way. Right? So let's see how. So if this works, then we're getting the correct direction, right? We're just maybe not getting the strength, right? The calculation for the strength. And that's falling in the right direction. So we're basically saying that that's right now. Okay, but the X and the Y is that going to work? It is normalized. Yeah, that's alright, that's going to work. I believe that's going to work. So we're good with that, right? So now what we want to do is we want to set up our wind strength, right? And because it's normalized, yeah, I think our calculation will work. Because if it's going in one direction, yeah, okay. We can probably set it as a ceiling, 1 and 1, right? And then we can multiply it. But our problem is, yeah, we can't really set a ceiling. So if we go with that, this is going to be a bit weird. But it's still okay. Because the X is going to be bigger and the Y is going to be slightly smaller, which is still fine. Right, I'm talking myself into this is okay. Right, this is still going to work. Right, so we basically have our wind, and all I need to do is pad it out now with the right values and we're good to go. Right, so go. Yep, yep, that's perfect. So, excellent. So, the next thing we're going to do is we're going to have a break, we're going to have a cigarette, and we shall be back in a couple of minutes. So, don't go anywhere. I'll be right back. Okay guys, we are back. So let's have a look at this. And that looks okay at the moment, right? So the next thing we're going to do is we're going to create a data table. Because we can, and we will. Okay, so we're going to have struct wind. Okay, and that's going to be dt wind conditions. And once we've got this, we're going to start setting up some values and checking it out. And we're going to add our wind conditions to the calculations when we do the wind. Right? So we're going to have a row name. I'm going to let it save first, I suppose. And what we want, we're going to do the row names by the E1 type, right? So that we can just do a straight up get the row ID. So we've got calm, gusty, strong, storm force. Okay. So we can say calm, we can say gusty, we can say strong, and storm force. And we can do that. We could have sorted on this, but since we're just doing this anyway, we'll just set up the row IDs so that we don't need to do and that's going to be storm force. We're not going to need a direction, and then we'll just set up our mins and maxes. Okay, so we're going to set up our storm force. We'll say minimum strength 4, maximum strength 6, and this is going to be kind of crazy. We're not going to do anything with gust yet. The calm, it's going to be that. So min strength is going to be 0, max strength is going to be 0.1. Right, then gusty, we're going to have min strength 0.2, max to 0.5, and then strong, we'll have 0.5 to 2, let's say. Save that. Then we're going to go into our wind component, right? We're going to delete that, And on begin play, we're going to get our attributes. We're going to break that. We're going to get our E1 type. Then we're going to switch on that. Right, now the only two that it's going to be different is the random and then the rest. Right. And then get data table row name. Sorry, get data table row. Right. And then we're going to get win conditions. Right. And these are going to all go in here. Then we're going to get this. And we're going to say enum string. And then that's going to go in there. Right. Then we're going to set this to that. Right. Now, if we do the random, we're going to get data table row names. Right. Then we're going to get the win conditions. Then we're going to get the length. And we're going to say -1. Then we're going to get random integer. I don't think it's get, it's just random integer range. And we don't want 0 because, yeah we do, because it's not there. Right, so we do that. Right. Then we get a copy. And we plug that in there. Then we do that. That goes in there. This goes in here. And that gets our win for us. Okay. So you can drag that down a bit. Right. You can drag that over there a bit. And then drag that over a bit. Drag this down a bit. And there we go. Okay. And we can straighten to get a copy. That keeps us nice and tidy. Right, and then we can go to our bomblet. We can delete this. And for purposes of working, we can break that. And then basically we multiply and we duplicate that. Okay, apparently we don't, so I'm going to copy paste it instead. Then we're going to get our Y, that's going to go in there. Then we're going to take our maximum strength and we're going to multiply it just to give us the crazy numbers. We still need to do the random value of what our wind is at, right? So now, if we set our attributes and we say storm force, now it should blow that way in a crazy direction, right? And we should get a whole load of movement, okay? And then we can test it on cam and we should get very little movement. And what we can do at that point is multiply the mass as well, so that when we actually build our different bomblets, if it's heavier, then it won't affect it so much, and if it is or lighter, then it will. So we can include that in our calculation. So in theory, this should blow a blooming lot, as you can see. Okay. Now, it's obviously a bit exaggerated, but we could do cam. And let's see how that one goes, shall we? Right, so we can gradually expand on our wind component, right? But this should be not an awful lot. Yep, there you go. We have a cam just a little bit of movement there, which is good. Now the interesting thing here is, right, what I want to do is I want to run that again, right? And what we want to do is we want to go higher. Okay. And we're going to have to obviously do something with our HUD that's going to indicate the wind strength, right, as well, so that you've got an idea of which way the wind is blowing. Right, so as you can see, we're at 11 meters, right? So you'll notice that on a calm day, it was hitting when we were at 11 meters, right? Now, if we go up, right, the question is, does this hit? And the answer was yes, right? I'm going to have to do that again, right? Because I'm going to have to basically put it right up a bit. Right, so we're going to have to go up to, like, let's say 80 meters or something. I'm not sure. I'm going to have to watch some of these videos again and see how high these drones are flying. When they're actually dropping bottles of water or delivering stuff or dropping bombs or grenades or whatever it is they drop. But we're going to have to check to see what the average is, and it's going to have to be taken into our calculation. Right, so we're at 11 meters just now. Right, we're at 30, we're at 60, we're at, let's see, let's put it to 100 meters, right? Right, so we're at 100 meters. Right, now what we can do here is we can zoom in. Right, but we are at 100 meters, so if we drop, you'll notice we're way off, which is kind of what you'd think, right? And that is kind of interesting. Now, the really interesting thing, of course, is if we do the exact same thing, right, but we make it a strong wind and do the exact same thing, right, it should be miles off. And the question is going to be, when we do this, is how strong we make the wind, right? So I'm actually going to have to check on some actual calculations of how much the wind has an effect on things in the real world, like dropping something like a grenade, which is 0.25 kilos. Right, so we can see there, right, and we can zoom out, and we can go to our 100 meters, then zoom in, right, so let's go to our 100 meters, right, that's bang on, then we can zoom in. I think it was 6 times or something, wasn't it? Maybe it was 8. Right, So let's see. And you can see it is blooming miles away. Right, so we can zoom out again. And we can see where that ended up. Right, that's over the other side of the planet. Right, so I think we need to tighten that up a bit. But you can see the amount of yeah, you can see the amount that's basically putting us off. But the good thing is, oh, that's way over there. Right, so that gives us another really nice. Right, so basically what we're saying here is that if it's windy at all, you're going to be struggling to hit anything. Right? But I don't know, what do you guys think? Is that a reasonable thing or not? Right, but that's pretty cool. Right. But that's good, actually, that's not a bad gameplay element, right? Because if you're 100 meters up, right, 100 meters is quite high, and basically if you're trying to, let's say we've got a trench, right, you're trying to drop a bomblet in a trench, right, if you go down near the trench, then obviously the bad guys are going to be able to shoot you, but the trade-off is that obviously, so let's think about this, right? We've got a strong wind, right? So if I try to drop it, let's say I've got an indicator up in the top right that says the wind is strong today, you know, blah 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 blah, and that is my position for dropping it. Did I change that to calm again? I think I did. Damn it. So let's try it. We did put it to calm, right? So let's put to strong. Right? Now let's see if I can actually judge this and do it. And if I can, I'm calling it a mechanic. Right? If I can do this first time, I'm calling it a mechanic. If I get close and I can blow up the ammo crate, right, I'm calling it. Right. That's not bad. Right, so we're going there, right? We're at 11 meters and we're dropping. Right. I'm getting closer. Oh, there you go. Now, the problem is, if we're in the same place and we zoom up and then we drop, oh, that's not so good. Right. Now, what I suggest we do here is that for the first X amount of time, it is not affected. Right? So when you first drop it, it's like, let's say half a second, that the wind does not affect it. Okay? So that it so you get the idea that it's dropping straight down at first, and then basically the wind catches it. But yeah, that's working really good. And I think, guys, I'll call it there. I'm going to have a tweak about with it. I'm going to play with it a bit. I'm going to add probably some gusts into it. I'll be back later at 8:30. So check out some more videos. It's good to be back. It's good to see you back again, Sunbuster. Or my namesake, who just, his mother made a syntax error. Right. And I shall see you at 8 tonight. So, thank you for joining. Bye bye for now.